So the question reads to say W, X, Y, and Z are points on the surface of the Earth as shown in the diagram below. Okay, W, X, Y, and Z are points on the surface of the Earth as shown in the diagram below. Take pi as 3.142 and R is equal to 34.37 Newton-meters. This is what we have here. So this is the diagram, whereby in this diagram we have point X, we have point W, X, Y, and Z. These are the 4 points that we have on this question. Then the first question reads to say calculate the difference in latitude between W and Y. Calculate the difference in latitude between W and Y. So to calculate the difference between W and Y, what do we do to calculate the difference here? So when we concentrate on W and Y, whereby we have to find the difference between W and Y. So W and Y, they are actually lying on the same longitude. W and Y, they are on the same longitude. So when the points are on the same longitude, it means that the difference is on the latitude. So if we correct the coordinates of W, which will be W, open bracket, so W as the latitude of 80 degree north, so 80 degree north, comma, W as the longitude of what? 15 degree west, so we have 15 degree west, close. Then what about Y? So Y as the coordinate of the latitude of Y, it is 30 degree south, comma, then the longitude of Y, it is 15 degree west, so 15 degree west. So as you can see, the coordinates are in the form of latitude and the longitude, even here latitude and the longitude. So W and Y has the same what? Longitude. So when the longitude is same, that simply means that the difference, it is on the latitude. As I said, W and Y, they are on the same longitude. So the difference, it is in a latitude. So that simply means that you're going to get 80 degree north and 30 degree south. Now this is north and this is south. So same different hemisphere you add, since this is north and this is south, so the signs are different here. So different hemispheres you add. So we're going to say the difference between W and Z and Y, the difference between W and Y is equal to, we're going to say 80 plus 30, which is giving us, so when you add 80 plus 30, you're going to get 110 degree. So this was the difference between Y and the W and Y. So this is how you can answer question 1, calculate the difference in a latitude between W and Y. So the difference between W and Y was 110. Okay, we go to question B, numero 2. This was question numero 1. So go to numero 2. So numero 2, they are saying that calculate the distance in Newton-meters between A, X, and Z along the circle of longitude 105 degree east. Okay, so we should calculate the distance in Newton-meters between X and Z along the circle of longitude 105 degree east. So to calculate the distance, now what formula are we going to use? Here we are calculating the distance of X and Z. So the distance of X and Z. So X and Z, they are lying on the same longitude. So when the coordinates are actually lying on the same, sorry, not coordinates, but when the points are lying on the same longitude, we use the distance is equal to theta over 360 2 pi r. This is the formula that you use to find the distance of the points that are lying on the same what? Longitude. Since x and y, they are on the same longitude, so we use this formula to calculate the distance between x and z. So now we're going to say our distance is equal to, what is the theta? So the theta, it is the difference between x and z. So x and z, they are lying on the same longitude, so meaning that the difference, it is in latitude. Since x and z, they are lying on the same longitude, it means that the difference, it is in latitude. So meaning that we're going to add 80 degree north plus 30 degree south. What I'm saying here is that when we try to correct the points of x and z, when we try to correct the coordinate of x and z, so x, it is 80 degree north, comma, then x again, it is only 105 degree east. Then what about y? Z, x and z, not y. Z. So z, it is on a latitude 30 degrees south and the longitude 105 degree east. So you can try to say that this and this is the same. They have the same longitude. So the difference should be in what? In latitude. So we add 80 degree north plus 30 degrees south because of different hemispheres. So that's the reason why I'm adding. So when you add 80 plus 30, you get what? 110. So 110, it is the difference between x and z. So now where there is theta, we're going to put 110 over 360 times 2 times the pi, it is 3.142 times. The question has said we should calculate the distance in nautical miles. So nautical miles, the r will be 3437. So where there is r, we put 3437 nautical miles. So therefore distance is equal to, so we're going to multiply 110 times 2 times 3.142 times 3437 on a calculator. Okay, so we're going to multiply 110 times 2 times 3.142 times 3437. So when you multiply, you get something like this. Then this answer, we now divide it over what? 360. So I'm going to divide the same answer with what? With 360. So you get this when you divide. So when you divide, we're going to get 659.4218889 nautical miles. So therefore our final answer will be the distance, it is 6599.4 nautical miles. So this is the final answer here. So this was the distance between x and z. This was the distance between x and z. Then we go to B. B, it is telling us to calculate the distance in nautical miles between y and z along the circle of latitude 30 degrees south. Okay, y and z along the circle of latitude 30 degrees south. So here we are calculating the distance between y and z. Okay, between y and z. So where is y and where is z? So y and z, they are here, y and z. So y and z, they are lying on the same latitude. They are lying on the same what? Latitude. So when the points are lying on the same latitude, therefore to calculate the distance, we use the formula which states that distance is equal to theta over 360 2 pi r cos x. This is what you do. We use this formula to find the distance of the points that are lying on the same latitude. So we're going to say our distance is equal to, what is the theta here now? What is the theta? So the theta, it is the difference between y and z. So y and z, they are on the same latitude, meaning that the theta or the difference should be in the longitude. Okay, the difference between y and z should be in the longitude because y and z, they are on the same latitude. So when we correct the point y, it will be what? 30 and 15 there. So this will be 30 degrees south, what? 15 degree west. Then what about z? So z, this will be 30 and 105. So 30 degrees south, 105 degree east. So as you can see, 30 south, 30 south, it is one and the same thing. So the difference, it is on the what? On the longitude. So the difference now, we have west and east. So different hemispheres we add. This simply means that we have to add 105 plus 15. That's what we have to add. So when you add 105 plus 15, you get what? 120. So that simply means that when you add 15 plus 105, you get what? 120 degree. So theta, it is now what? 120 over 360 times 2 times the pi, which is 3.142 times the r, which is 3437, because we are calculating the distance in nautical miles. So it is 3437. So we say 3437 cos. Now what is cos x? So x, it is the common number between y and z, or x, it is the latitude. In short, x, it is the latitude. So the latitude between y and z, it is 30. As you can see, y and z, the latitude is what? 30. So we put cos what? 30 here. Okay, we put cos 30 here. So therefore, from there, we're going to say our distance is equal to, we multiply 120 times 2 times 3.142 times 3437 cos 30. So this is what you multiply. So we are multiplying 120 times 2 times 3.142 times 3437, then cos 30. This is what you're multiplying. So you're going to get something like this. So when you multiply what is on top, you are getting this answer. Then this answer, now we divide it over 36. So when you divide by 36, you're going to get this answer here. So after dividing by 36, I'm getting something like a 62.34.836734 nautical miles. So therefore, our final answer will be distance is equal to 62.34.80 nautical miles. So this is our distance between y and z.